Here in 2.3.3, negative integer power of x, our goal is to show that the power rule also works for monomials in which the degree of the exponent is a negative integer. So for instance, we know that the power rule works on something like x to the fifth, but we're going to show that it also would work on something like x to the negative fifth. So we begin with that rule. The rule for differentiating negative powers of x is the same as the power rule for differentiating positive. So whether that power is negative or positive, it works the same, although the proof is different. The proof, if you're looking for it, is on page 127 of your textbook. I'll leave that to you, but the power rule for negative integer powers is the same as you would expect. The derivative with respect to x of x to the n is n x to the n minus 1. N becomes the coefficient out front. We reduce the exponent by 1. So let's see that in an example. Find an equation for the line tangent to the curve of y equals x squared plus 3 all over 2x. Now, we could use the quotient rule here, but I'm going to argue that we probably shouldn't, because the quotient rule, well, number one, it's a little more complex than other rules we have, such as power or product, and this function can be rewritten. I like to look at this as x squared over 2x plus 3 over 2x. And that's going to simplify again. X squared over 2x is the same as 1/2 x, because we have a 1 coefficient over a 2 coefficient, and x squared over x. Then plus 3 over 2x, that's the same as 3/2 x to the power of negative 1. And so now here we are with a monomial plus another monomial, and we can use the power rule. So dy dx, the derivative of y with respect to x, will be the derivative of 1/2 x, which is 1/2, and then the derivative of 3/2 x to the negative 1, which will be minus 3/2 x. Now, we subtract 1 from negative 1, so negative 2. And then that can simplify to 1/2 minus 3 over 2x squared. All right, we are looking for the line tangent to the curve at the point 1, 2. So dy dx evaluated at x equals 1 is going to look like this: 1/2 minus 3 over 2 times 1 quantity squared. So this is 1/2 minus 3/2 for negative 2/2, which is negative 1, as the slope of the tangent line, which means then our tangent line is going to be an equation y equals the slope, negative 1, times x minus the x value of our point, plus the y value of our point. And we want to confirm this graphically, so let's pull back up our calculator and let's put it over here. Turn him on, go to the y equals screen. Let's graph our function, which is x squared plus 3 over 2x. And let's clear y2 and graph negative x minus 1 plus 2, and let's zoom decimal for a nice even showing. Here's our function, 2 pieces to this one, and here comes our supposed tangent line, and I absolutely believe that's the correct tangent line at the point 1, 2. So we did all right there, and I hope you see me for another video.